Hey, good evening. In your case, good afternoon, everyone. So it's 9:30 p.m. and I've got to blast this out so I can get home to watch Castle. But I'll still try to do a good job. So, welcome back from Canada. I hope you all had a good trip and you're all safe and not hospitalized. So, 7.2 is integration by parts. In 7.1, recall that substitution goes with the chain rule. Substitution for integration, I should say, goes with the chain rule for differentiation. Okay? Take the derivative using the chain rule. You'll wind up using substitution to integrate that. So 7.2, we're going to talk about if you use the product rule for differentiation, what do you use for integration? Well, you use integration by parts. These two correspond. I guess I should go arrows both ways because you can go both ways. Okay, so that's our general direction today. And you're going to hate me for this, but I'm going to show that a little bit. Maybe I should even leave this here. Okay, so you recall in integration by parts that if you were doing the derivative, now the derivative, not the integral, of some function f of x times g of x. Obviously, f of x times g of x, it's a product, so you use the product rule, which as you recall was the first function times the derivative of the second plus the second function times the derivative of the first. And you all did very well when we went through the product rule. No worries. So if I wanted to take this part right here, the second part of this, and clone it, move it down here, and you know what I'm going to do. Take the integral of that product rule result. What should I get? Riddle me this, Batman. Well, of course, you get the original product, f of x times g of x. Okay, not so bad. And of course, because we're taking a product, I have to put in here d of x, keep everything legit. And because I have a product here plus a product here, I can break these parts up. So I can say the integral of f of x times the derivative of g of x plus the integral of g of x times the derivative of f of x equals f of x times g of x. And of course, don't forget my g of x to keep it legit in here. Okay, looking good so far. Now, if we subtract this part right here from both sides, we're going to wind up with integral of f of x times the first derivative of g of x dx equals f of x times g of x minus the integral of g of x and f prime of x dx. Now, I know your eyes are starting to gloss over, but it's really not that bad. Take a few minutes and study this over if you want. Now is a good time to pause. It's really not that bad. And in fact, to make it a little bit better, I'm going to say, and you know I love substitutions, and that's why we did 7.1 first. I'm going to say, let u equal f of x, and let v equal g of x. And we can do that. And then we can make our lives a whole lot easier. We can say that this is the integral of u dv equals u v minus the integral of v du. And this is what you commonly see when using integration by parts. It's just not as intimidating as all of this stuff up here, but it is the same thing. Okay, so that's the first part. That only took us 6 minutes and change. Let's do an example. Okay. Oh, heck, let's celebrate. Let's use a pleasant green for our example. Okay, so this is going to start off looking really simple and wind up not being simple. So hold on to your hats, everyone. It's going to be a wild ride. So we have the integral of e to the x times sine x dx. Okay, to start with, let's let u equal e to the x. This one is fairly straightforward. In general, for a future frame of reference, you want to pick a u that is the component that becomes simpler when you take its derivative. In this case, it doesn't really matter. When you take this derivative, it's not that big of a deal. Du dx equals e to the x. Du equals e to the x dx. And we're going to need that. We also need to pick dv. And this is a little different. We're actually picking the derivative of something. The only thing we have left here is sine x, so we can say dv equals sine x dx, and so that v would equal, think about it for a minute, if the derivative of v equals sine x dx, what does v equal? Well, of course, it's the opposite of cosine x. Pretty cool. Pretty cool. Okay? And go through that checklist. I need a U, I need a DU, I need a V, I need a DV. And you need those items. I'll put little dots by them. I need 1, 2, 3, 4 items to make this work. Because there's 1, 2, 3, 4 items here. Okay? All right, now let's try it out. The integral of e to the x sine x dx. Okay, so we've got e to the x, that's our u. We've got sine x, that's our dv. So we've got integral of u dv. Good to go. Okay, and let's keep that in mind as we write this out. So now we've got the integral of e to the x sine x dx equals, okay, so then I need a uv. What was u? E to the x. And then I need a v. What was v? Opposite of cosine x. I'm going to put this in parentheses so I don't try to subtract. Times opposite of cosine x uh, minus the integral of v. What was v? Negative cosine x times du times e to the x dx. See, it's not so bad. It's not so bad. Now here's the really crazy part. Well, wait, let's clean this up one more before I get going, okay? So now we have e to the x times sine x dx equals, well, normally you're going to go the opposite of e to the x cosine x. Okay, we got a minus there and a minus there, so we're going to go plus the integral of cosine x. Well, all right, I'm going to do it. I'm going to write it in the same order just to be consistent. Plus e to the x cosine x dx. And at this point, you're probably thinking, dude, that didn't get easier. It, it did not get easier. And you are right in some ways, but here's a good trick that we haven't done before. You can do this again. Number one, number two, I can do it again. It's okay. So again, I can say, okay, let u equal e to the x. I better extend the page. Let u equal e to the x. I can tell I'm going to need just a little bit more here. And then du equals e to the x dx. You're getting used to that by now. And then we can let dv equal, in this case, we had e to the x, we have cosine x. See, I'm going to just integrate just this part. dv equals then cosine x dx, and then v would equal sine x. I can do it again. And this is really cool. So just hang in there with me. It's not as bad as it looks. I'm going to do this part for just this right here. Okay? Just that right there. Don't freak out. It's going to be all right. Okay? So just that part. So I've got, I'll do it in blue just to keep it cool. The integral of e to the x cosine x dx. And again, maybe I should write this up here just to keep it cool. So the integral of u dv equals uv minus the integral of v du. There's integration by parts. Now let's plug in what we said. So we've got u e to the x, and we've got dv cosine x dx. So then it's going to be equal to e to the x times sine x. Okay, so far so good. E to the x times sine x, that's my u and my v, minus the integral of v, which was sine x, times du, which is e to the x dx. Okay, maybe I should move that arrow a little bit. A little bit in the way, not bad. Okay, so that's just that part. E to the x cosine x, just this part, the integral of e to the x cosine x dx equals e to the x sine x minus the integral of sine x e to the x dx. And I know what you're thinking. You're saying this will go on forever. I'll always wind up with some kind of an integral here that's basically the same thing that I started with. And it seems that way. But let's go back to green and see what we have. Using this part right here was our original, minus this part, plus what we just did. This is the blue part right here. And let's just see what we get, and you'll be surprised, okay? So we're going to go back to green. And so now we have, get rid of that. I should have left it the way. I think I had it right in the beginning. So we're going to go back to green. And so now we have the integral of e to the x sine x dx equals. Okay, we can keep this part here. We can just bring that down. The opposite of e to the x cosine x plus. Okay, here is the part we just did. Was the part in blue? Integral of that. And out of that, we got this plus, I'm going to bring this down, e to the x sine x minus the integral of, okay, I should change that around too. Um, and you'll see why in a minute. So I'm going to bring this part down, but I'm going to put e to the x sine x dx so that I'm consistent. See, because I put e to the x here, okay? Integral there, got that, got that. Now, check this out. Here's where it gets cool. I know I'm a math geek. Here's an integral of e to the x sine x dx. Here's an opposite of integral e to the x sine x dx. Same thing. Check it out. So I can subtract e to the x. No, not subtract. I got to add because this one's already negative. See where we're going? I love it. Okay, and I can add integral e to the x sine x dx on this side. It's going to be great. And you're rolling your eyes. Give me the eye roll. Who eye rolls in here? Um, Liz Olson probably can do it. Melissa can probably do it. Give me the eye roll. You're thinking, this is crazy. So now how many of these I have? I have 2 times the integral of e to the x sine x dx. It's not that bad. There's 2 of them. Check it out. There's 2 of them. Okay. Then, let's just keep going. I've got equals, bring this down, negative e to the x cosine x plus e to the x sine x. You see what I'm getting at? All the integrals are on one side. All the other stuff is on the other side. We were just trying to get a single one. Now we got 2. I'm not scared because it let us, we can get rid of this. We can do it. Okay? You see where I'm going? And you already see it. You can say it. Integral e to the x sine x dx equals, say it with me, 1/2 times the opposite of e to the x cosine x plus e to the x sine x. Okay? And from here we can clean it up a little bit, but basically you're done. The integral of e to the x sine x dx equals, okay, notice there's an e to the x in this term and an e to the x in this term, a plus in between, so we can factor it out. So we can say 1/2 e to the x times, and normally, you don't have to, because normally this is a minus, this is a plus, you'll just go sine x minus cosine x, and then don't forget plus c. Isn't that the coolest thing you've ever seen in your life? Put a box around your answer and feel happy because you are amazing mathematicians. Okay, so that is integration by parts. I'm I was going to say I hope you enjoyed this, but you probably didn't, but this is powerful, powerful stuff. Integration by parts is the corresponding integration that goes with the product rule for differentiation. The product rule and integration by parts go together. They're evil twins, separated at birth, whatever. And the good trick here was using uh, U substitution twice. Pretty cool. Using the integration by parts formula. I'm a little bit exhausted, but a lot happy. And I wish you were with me today, or I wish I was with you. But either way, I'll be back tomorrow. Enjoy. Talk amongst yourselves about daughters and coffee and lofts. Good night.